students, and welcome to today's lesson. I'm Mrs. Miller. Today, we will explore the question, why does the moon look the way it does from Earth? Are you ready? Grab your pencil and your science journal, and let's get started. Have you ever seen the moon in the night sky? Maybe it looks something like this. How would you describe the shape of the moon in this picture? Do you notice that the moon is almost a perfect circle? This is a full moon. What else do you notice about the moon in this picture? It looks bright and lit up. When a full moon is viewed from Earth, the entire moon appears bright. Why do you think the moon looks bright from Earth at night? Do you think the moon emits light like the sun? Maybe. Remember, emit means to give off. When a light source emits light, it gives off light. We know the sun is a light source, so it emits light. But is the moon a light source? Or maybe the light from the sun illuminates the moon. We're not sure yet. So let's continue to explore the question, why does the moon look the way it does from Earth? To answer this question about the moon's appearance, let's gather information about how we see objects on Earth. We created this model to help us understand light. How can we see objects that emit light? The objects emit light rays that travel into our eyes, right? But not all objects emit light. How might we see objects such as a pencil or notebook that do not emit light? Well, we can't see objects such as pencils or notebooks in the dark, so I know we need light to see them. But objects such as pencils and notebooks block light. Let's investigate how a light ray can help someone see an object that does not emit light. What tool could we use to create a single light ray in the classroom? We could use a laser pointer. It makes one ray of light that we can point at something. But a laser pointer could be dangerous. It could damage a person's eyes. Maybe we could use a flashlight instead. How can we show just one light ray from the flashlight? Did you say we can use something to cover the lens? Maybe a piece of cardboard. Then we could poke a hole in the cardboard. That's a great idea. I made a light ray box for us to use. This is the flashlight hole. When I place a lit flashlight behind this hole, only a small amount of light enters the box. Shining a flashlight through a pinhole is like shining a single light ray. How can we use this box to study just one object and one light ray? I think we could open the box and put an object inside. Then we could look closely as we shine a light ray on the object. Do you think that would work? I think so. We can use this eye hole on the light ray box to observe an object inside the box, while a light ray enters the box through the flashlight hole. What object should we use? How about this pencil? This is what the pencil looks like without the flashlight. And this is what the pencil looks like with the flashlight shining through the flashlight hole. What do you notice? Well, when the light is off, we can't see the pencil very well. But when the light is on, we can see the pencil, and one side of the pencil looks very bright. Great observations. What do you think happens to the light ray once it reaches the pencil? Do you think the light ray just stops? Or maybe the light ray turns toward our eye. To collect more information, maybe we should observe light striking the surface of another object. Let's watch what happens when we shine this flashlight at a mirror. Wow! Do you see that? Why can we see light rays from the flashlight on the wall? I think the light rays bounce off the mirror, then onto the wall. Do you agree? Light travels in a straight line to the mirror, and then it gets redirected to the wall. The light ray bounces off the surface of the mirror. This is called reflection. Reflection is when a light ray bounces off the surface of an object. We saw reflection when the light ray hit the surface of the mirror. Do you think a pencil can also reflect light? Give me a thumbs up for yes, or a thumbs down for no. Let's replace the mirror with the pencil and look for evidence of reflected light on the wall. Ready? Does the pencil reflect light? Hey, I see light on the wall. Do you see it too? Thumbs up. The light on the wall is evidence that a pencil can reflect light. Let's create a light ray box model. What should we include? We need a flashlight, pencil, and an eye. Let's show a light ray traveling from the flashlight to the pencil. And then let's show the light ray being reflected from the pencil to the eye. This looks great. Now let's add an explanation. Let's say we can see the pencil when light rays from the flashlight are reflected off the pencil and enter the eye. So, how do we see the pencil? Light rays from light sources, such as the sun or a light in a room, are reflected off the surface of the pencil. Then those light rays enter our eyes. When the light rays enter our eyes, information is sent to the brain, and the brain recognizes the object as a pencil. Let's revise our light model. What should we add to the model to explain how we see the pencil? I think we need to add that rays of light reflect off the pencil to our eyes. Anything else? Hey, maybe we should show a brain too. Now let's update our explanation. We already have light rays can enter our eyes directly, so let's add or be reflected off objects like the pencil and then enter our eyes. Great job! So far, we have described two processes. We have described how we see objects that emit light, and we have described how we see objects that do not emit light. Let's list some similarities and differences between the two processes. In both processes, light goes from a light source to our eyes. Oh, and both processes involve light rays traveling from an object into an eye. Do you notice any differences between the two processes? I noticed that for us to see an object that does not emit light, light from a light source needs to be reflected off the object. But an object that emits light is visible even without light reflecting. Remember this photograph of the moon from the beginning of our lesson? Think about what you know now about light. How can this information help explain why the moon looks bright? Your task for today will be to answer this question. I can't wait to keep investigating. Let's review your task for today. Answer the question about why the moon looks bright.